Now in this lecture we'll find out the ratio between two radii. In the drawing we have a big circle. Inside this big circle we have two smaller circles. You know that the radius of this circle is equal to b, and the radius of this circle equals to a. And our mission is to find out the ratio between the radius of this circle that is b to the radius of this circle that is a. That is to say, to find out the ratio of b over a. In addition, we know that inside the biggest circle we have the right triangle ABC that is partially located inside the biggest circle. We also know that side AB equals to 5 units, side BC equals to 12 units, and this circle is blocked by the right triangle ABC. This angle equals angle ABC equals to 90 degrees, and we also know that AN equals to NC. Again, our mission is to find out the ratio of B over A. So first of all, we'll implement the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem in the right triangle ABC, AC square equals to AB square plus BC square. So I write it down. Here by PT is evaluation for Pythagoras theorem. AC square equals to AB square plus BC square. Okay. So AC square equals to AB square. AB is 5, therefore AB square is 5 squared, that is 25, plus BC square. BC is 12, therefore BC square is 12 squared, that is 144. So AC square equals to 25 plus 144, that is 169. We take a root out of this equation, and we get that AC equals to the square root of 169, that is 13. So we found out that AC, that is the hypotenuse of the right triangle ABC, equals to 13 units in its length. And because of the fact that AN equals to NC, it means that at point N, the hypotenuse AC is bisected into two halves. The first half is AN and the second half is NC. So we can write down that AC over 2, that is actually 13 over 2, equals to the first half is AN, the second half is NC. Okay, so AC over 2 equals to 13 over 2 equals to AN equals to NC. That is to say, AN equals to NC equals to 13 over 2. Each half equals to 13 over 2. So here the second half NC equals to 13 over 2. The second half of the hypotenuse AC is 13 over 2. Okay. So in the next step I will present to you a new rule number 8, and we implement rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to R equals to A plus B minus C over 2. We have the right triangle ABC, angle ABC equals to 90 degrees, the length of AB, side AB is A, side BC equals to units in its length, and the length of the hypotenuse AC is C. And we also know that the radius of this circle is r. So the right triangle ABC blocks this circle, that its radius is r. And according to rule number 8, we can know the radius of this circle that is blocked by the right triangle only by knowing the side length of the right triangle that blocks it. That is to say, the radius r will be equal to a plus b minus c over 2. Again, the radius r of the circle that is blocked by the right triangle ABC will be equal to a plus b minus c over 2. So we can actually implement rule number 8 in our drawing. Because in our drawing, we have the right triangle ABC that blocks this circle, and the radius of this circle is A. So according to rule number 8, the radius of this circle A will be equal to AB plus BC minus AC over 2. Again, the radius A, according to rule number 8, will be equal to AB plus BC minus AC over 2. So, writing down, the radius A of the circle that is blocked by the right triangle ABC will be equal to AB plus BC minus AC over 2. AB is 5, BC is 12, and just right now found out that the length of the hypotenuse AC is 13 over 2. 5 plus 12 is 17, 17 minus 13 is 4, and 4 over 2 is 2. So finally we found out that the length of the radius A of the smallest circle is equals to 2 units. A equals to 2 units in its length. Here. A equals to 2 units. We define the center of this circle as P. We define the center of this circle as Q. And we define the center of the biggest circle as O. This is the center of the biggest circle. It is defined as O. Okay. We define the point of tendency of tangent AB with this circle as T. We join points P and T together by a straight line. Point P is the center of the circle, point T is the point of the circle itself, therefore PT is the radius of the circle that is equal to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we define this, the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle, and therefore tangent BC will be perpendicular to the radius NP. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Angle ABC also equals to 90 degrees, of course. So in quadrilateral PTBN, we have 1, 2 right angles. The sum of right angles is 90 times 3, 270 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees. So inside quadrilateral TPBN, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral TPBN as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle TPBN, PN must be equal to TB, but PN is 2, therefore TB must be also equal to 2. Likewise, in rectangle TPBN, TP equals to BN, but TP is 2, therefore BN must be also equal to 2. It is given us the question that BA equals to 5. BA equals to 5, BT equals to 2. So BA minus BT is 80 again. BA minus BT is 80. So BA is 5, BT is 2, so 5 minus 2 is 3. So 80 equals to 3 units in its length. And we have here rule number 2 that states that the lengths of two tangents from a common external point to a circle are equal. We have the common external point A. From the common external point A, we have two tangents to the circle, tangent AT and tangent AM. And according to rule number 2, they are equal to each other. That is to say, AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We have already found out that AN equals to 13 over 2. AM is 3, so AN minus MN equals to MN. AN minus MN equals to MN. I'll write it down. AN minus MA equals to MN. AN is 13 over 2, minus AM is 3, is equals to, here we take, multiply minus 3 by 2 and then divide it by 2 in order to a common factor be 13 over 2, and we get that 13 over 2, minus 3 times 2 is minus 6, so 13 over 6 is 7, so in total this expression equals to 7 over 2. So finally we found out that Mn equals to 7 over 2. Mn equals to 7 over 2. Here, this line segment Mn is equals to 7 over 2. In the next step, I will present to you a new rule number 7, and we will implement rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects a chord, then the line segment is perpendicular to the chord. Here point O is the center of this circle. From point O, we draw line segment line segment OM that bisects chord AB. That is to say, AM equals to MB. And whenever you draw a chord from the center of the circle that bisects the chord, again, whenever you draw a line segment from the center of the circle that bisects the chord, then the line segment will be also perpendicular to the chord. In this case, it means that OM will be also perpendicular to chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. Okay, so we can implement rule number 7 in our drawing. Point O is the center of the bigger circle. So we join point O and N together by a straight line. From the center of the bigger circle, that is to say from point O, we have line segment ON that bisects chord AC. And according to rule number 7, line segment OM must be also perpendicular to chord AC. That is to say, ON is perpendicular to AC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So I write it down. This angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. So I can write down that ON is perpendicular to AC. In addition, point Q is the center of this circle. Point N is the point of the circle itself. Therefore, Qn is the radius of this circle. It is equal to B units in its time. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So you can write down that the radius QN is also perpendicular to tangent AC. QN is also perpendicular to tangent AC. The radius QN is perpendicular to tangent AC. And from those two equations, ON is perpendicular to AC and QN is perpendicular to AC, we derive that point O lies on the radius QN. Point O lies on the radius QN. Point O lies on the radius QN. Point O, this is point O, that is the center of the bigger circle. It lies on the radius QN. Why? Because if point O doesn't lie on QN, for example, if point O lies here, not on QN, then if we join the 2 points N and this point together, this angle will never be equal to 90 degrees. Here it will be less than 90 degrees. So point O must lie in QN in order that ON will be perpendicular to AC. Because of the fact that QN is perpendicular to AC at point N, then ON will be also perpendicular to AC at point N only if O lies on QN. Okay? So So if O lies on QN, it means that QON is one straight line. QON is one straight line. Okay. All the 3 points Q, O, and N are located on the same straight line, or QON is one straight line. QON is one straight line. Line segment QON is one straight line. This point is the point of tendency of this circle with the biggest circle. So we define the point of tendency as U, and then we draw tangent VW, that is tangent at point U to both circles. So this is tangent VW is tangent to both circles at point U, to this circle and to the biggest circle. Point U is the point of tendency. So here, point Q is the center of this circle. Point U is the point of the circle itself. Therefore, U is the radius of this circle. The radius of this circle. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees. So I can write down that the radius QU is perpendicular to VW. The radius QU is perpendicular to tangent VW. In addition, we know that point O is the center of the biggest circle. Point U is the point on the biggest circle itself. This is exactly the definition of a radius. So OU is the radius of the biggest circle that we will define as x. The radius of the biggest circle is x. So the radius OU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. And therefore, tangent VW will be perpendicular to the radius UO. If VW is perpendicular to UO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So you can write down that the radius of the biggest circle OU is also perpendicular to tangent VW. OU is perpendicular to tangent VW. And from those two equations, QU is perpendicular to VW and OU is perpendicular to VW, we derive that line segment OQU is one straight line. This line segment OQU is one straight line. That is to say, all the 3 points O, Q, and U are located on the same straight line. Why? Because if, for example, point O is not located on the same straight line as QU, for example, point U is located here, then OU will be this line segment. It never creates 90 degrees with tangent VW. QU creates angle of 90 degrees with VW at point U. In order that OU also will create 90 degrees at point U with VW, OU point O must be located on the same straight line as QU. Therefore, OQU is one straight line. So for one side we already found out, so that side now we found out that OQU is one straight line. We have already found out that QOU ON is one straight line. And from those two statements we derive that in total NQU is one straight line. NQU is one straight line. NQU, line segment NQU is one straight line. If NQU is one straight line, it means that NU is also a straight line. NU is a straight line. NU is a straight line. But NU is a straight line that touches the circle at points N and U. Therefore, NU is a chord. NU is a chord that passes through point Q that is the center of the circle, and any chord that passes through the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of this circle. NU is the diameter of the circle. And because of the fact that the diameter of any circle is twice as long as the radius, and the radius of this circle is b, therefore the diameter NU must be equal to 2b. NU or UN, it is the same. And write down also UN is the diameter of the circle that is equal to 2b. UN equals to 2b. Okay, in the next step we join points O and P together by a straight line. Point O is the center of the bigger circle. Point P is the center of the smaller circle. And at this point, the small circle touches the biggest circle, the smaller circle touches the biggest circle. We find the touching point as S. And in the next step, I present to you rule number 9. And we implement rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together must pass through their touching point. The center of the big circle is here at point O, the center of this small circle is here at point M. The straight line that connects their centers together is the straight line OM, and according to this rule number 9, the straight line OM must pass through point P. If OM must pass through point P, it means that OMP is one straight line. Again, OMP is one straight line. So we can implement rule number 9 in our drawing, because in our drawing we have the center of this, the biggest circle is point O, the center of the small circle, the smaller circle is point P, the straight line that connects the centers together is OP. And they touch each other internally at point S, and according to rule number 9, the straight line OP must pass through point S. That is to say, OPS is one straight line. OPS is one straight line. So we can write here that OPS is one straight line. Line segment OPS is one straight line. So if line segment OPS, if this line segment OPS is one straight line, it means that OS must be also a straight line. OS is also a straight line. Here OS is a straight line. So OS minus PS is PO. Again, OS minus PS is PO. I write it down. OS minus PS is equals to PO. What is the definition of the third line OS? The third line OS starts from point O, that is the center of the biggest circle, and ends at point S, that is the point of the biggest circle itself. This is exactly the definition for radius. So OS equals to X, that is the radius of the biggest circle, minus PS. P is the center of the smallest circle, S is the point of the smallest circle itself, therefore PS is the radius of the smallest circle, that is equals to 2A. A equals to 2, so PS is 2, so we substitute PS by 2. In conclusion, we found out that PO equals to X minus 2. So here, this line segment PO or OP equals to X minus 2 units in its length. In the next step, we will extend the perpendicular ON by a straight line. ON is a perpendicular, it is absolutely a straight line. And when we extended the straight line ON by a straight line, the result must be a straight line. So this is a straight line. If we focus on this side of this straight line at point N, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at this side of this straight line at point N? We have this angle is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. We know that CA is tangent to this circle at point M. Point M is the point of tendency. We join points P and M together by a straight line. Point P is the center of this circle. Point M is the point of the circle itself. Therefore, PM is the radius of this circle, that is equal to 2. The radius PM is 1 to point M, that is the point of tendency AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. In the next step, we will draw perpendicular on MP at point P. Again, we draw perpendicular on the radius MP at point P. So actually, here, this radius equals to 90 degrees according to our construction. And then we'll extend the perpendicular until it touches the extended ON. And we'll define the touching point as T. In this way, we created quadrilateral NMPT. Inside this quadrilateral, we have 1, 2, 3 right angles, therefore the fourth angle must be equal to 90 degrees. So inside quadrilateral MNTP, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral MNTP as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise, in rectangle MNTP, we have MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. We define the length of line segment NO as H. And in the next step, we'll implement the Pythagoras theorem on the right green triangle PTO. Okay, so I copy the right triangle PTO. In your present, we implement on it the Pythagoras theorem. PT equals to 7 over 2. We have already found out that the hypotenuse PO equals to X minus 2. And what is the length of OT. From the drawing, it is very easy to see that OT equals to ON plus NT. That is to say, OT equals to ON, that is H, plus NT, that is 2. So in total, OT equals to H plus 2. So you can write here that OT equals to H plus 2. This is the right triangle OPT. By PT is the version from Pythagoras theorem. The right triangle OPT, according to the Pythagoras theorem, PO square equals to PT square plus OT square. Okay? OP square equals to PT square plus TO square. So PO is x minus 2, therefore PO square is x minus 2 square. This is equals to PT square. PT is 7 over 2, therefore PT square is 7 over 2, that is 49 over 4, plus OT square. OT is h over 2, therefore OT square is h over, OT is h plus 2, therefore OT square is h plus 2 square. We'll open the brackets on both sides of the equation and we'll get that x minus 2 square equals to x square plus 2 square, that is 4, minus 4x, and it is equals to 49 over 4 plus h plus 2 square is h square plus 2 square, that is 4, plus 4h. Here we have, so I'll copy again the same equation here on the new page. Found out that x squared plus 4 minus 4x equals to 49 over 4 plus h squared plus 4 plus 4h. So this is the same equation that I copied it from here. In the next step, we join points O and C together by a straight line. What is the definition of the straight line OC? It starts from point O, that is the center of the bigger circle, and ends at point C, that is the point of the circle itself. This is exactly the definition for radius. So OC equals to x, this is the radius of the bigger circle. ON equals to h according to our definition, and NC equals to 13 over 2. So I copy the right triangle ONC in a new page, and we'll implement on this right triangle ONC the Pythagoras theorem. Actually, this is the right triangle ONC that I copied from the original domain. ON equals to h, NC equals to 13 over 2, and the hypotenuse OC equals to x. According to the Pythagoras theorem, this right triangle ONC, we get that OC square equals to ON square plus NC square. So OC is x, therefore OC square is x square, and is equal to ON square. ON is h, therefore ON square is h square plus nc squared. nc is 13 over 2, therefore nc squared is 13 over 2 squared, that is 169 over 4. So in conclusion, we found out that x squared equals to h squared plus 169 over 4. So we can substitute x squared in this equation by h squared plus 169 over 4. We'll do it now and we get that x squared is 169 and h squared is x squared is h squared plus 169 over 4 plus 4 minus 4x is equal to 49 over 4 plus h squared plus 4 plus 4h. So here we have h squared on both sides of the equation, so h squared will get cancelled. We have 4 on both sides of the equation, so 4 also will get cancelled, and we left only in this side of the equation by with 169 over 4 minus 4x, that is equals to 49 over 4 plus 4h. Here we subtract 49 over 4 from this equation, and you get that 169 minus 49 over 4 minus 4x equals to 4h. Here we add 4x to this equation and we get that 169 minus 49, 169 minus 49, it is 120. So in total this expression equals to 120 over 4 minus 4x, that is equals to 4h. Here we'll add 4x, we'll add 4x to this equation, and we get that 120 over 4 is 30, that equals to 4x plus 4h. So 30 equals, we take 4 as a common factor for these expressions, and we get inside the brackets we have x plus h. We divide this equation by 2 and we get that 30 over 2 is 15, is equal to 4 over 2 is 2 times x plus h. Here we will divide this equation by 2 and finally we will get that x plus h equals to 15 over 2. X plus h equals to 15 over 2. And we found out that x plus 8 equals to 15 over 2. So what is the length of line segment UN? On the it is very easy to see that UN equals to UO plus ON. Again, UN equals to UO, that is x, is the radius of the bigger circle, plus U plus ON, that is h. So in total UN equals to x plus h. So you can write down that here that UN equals to x plus h, UN equals to x plus h from one side, but from the other side we already found out that UN equals to 2b, it is the diameter of the circle. We can write here that UN equals to 2b, and from from those two equations, un equals to x plus h and un equals to 2b, we will derive that x plus h equals to 2b. X plus h equals to 2b. But we already found out that x plus h equals also to 15 over 2. So we can write here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b. We will derive that 15 over 2 equals to 2b. 15 over 2 equals to 2b. Here we divide this equation by 2 and finally we get that b equals to 15 over 2 over 2 is 15 over 4. So here the radius b of this circle equals to 15 over 4 units in its length, and we already found out that the radius of this circle a equals to 2. A equals to 2. Therefore the ratio b over a will be equal to b, that is 15 over 4 over 8, that is 2. 15 over 4 over 2 is 15 over 8, so in terms of numbers this is 1.875. So finally, if we found out that b over a equals to either 15 over 8, or in terms of numbers it is equals to 1.875. Okay. Again, the ratio between the radii of this circle and the radius of this circle, it is equals to b over 8, it is either 15 over 2, or in terms of numbers, it is equals to 1.875 units. In the next step, I will summarize the lecture. In this lecture, I found out the ratio between two radii, the radius of this circle that is b and the radius of this circle that is a, or the ratio of b over a. So in the drawing we have the biggest circle. Inside the biggest circle we have two smaller circles, those two circles. You know that the radius of this circle is b, the radius of the smaller circle is a. And we also have a right triangle ABC that is partially located in the biggest circle. This is angle ABC that is equal to 90 degrees in its size. Side AB equals to 5 units, side BC equals to 12 units. And we also know that AN equals to NC. Our mission is to find out the ratio of B over A. So first of all, we implemented the Pythagoras theorem in the right triangle ABC. The right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. Repeat again. In the right triangle ABC, according to the Pythagoras theorem, by PT is the version for Pythagoras theorem, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. 25 plus 144 is 169, therefore AC squared equals to 169. We took out of this equation and found out that AC equals to the square root of 169, that is 13. So the hypotenuse AC, this is the hypotenuse AC of the right triangle ABC, it is equals to 13 units in its length. And because of the fact that at point N, the hypotenuse AC is bisected to two halves, the first half is AN, the second half is NC. So you can write down here that AC over 2 is 13 over 2, the first half is AN and the second half is NC. That is to say AN equals to NC equals to 13 over 2. Each half of the hypotenuse equals to 13 over 2. Then we implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle is equal to r equals to a plus b minus c over 2. We have the right triangle ABC, angle ABC equals to 90 degrees, the length of side AB is A units, side BC equals to B units in its length, and the length of the hypotenuse AC is C units. The right triangle ABC blocks this circle. Okay, and the radius of this circle is R. According to rule number 8, we can know the radius of this circle that is blocked by a right triangle only by knowing the sides of the triangle. That is to say, the radius of this circle that is blocked by the right triangle ABC will be equal to A plus B minus C over 2. Again, R equals to A plus B minus C over 2. So we actually can implement rule number 8 in our drawing. Why? Because in our drawing we have the right triangle ABC that is blocked this circle, that blocks this circle, and the radius of this circle is A. So according to rule number 8, the radius of this circle A will be equal to AB plus BC minus AC over 2. Again, the radius of this circle is equal to A will be equal to AB plus BC minus AC over 2. I repeat again, according to rule number 8, the radius of the circle that is blocked by the right triangle ABC will be equal to AB plus BC minus AC over 2. AB is 5, BC is 12, and AC is 13. Therefore, AB plus BC minus AC is 5 plus 12 minus 13 over 2. 5 plus 12 is 17. 17 minus 13 is 4, and 4 over 2 is 2. So finally we found out that A, the radius of this circle A, equals to 2 units in its length. Here A equals to 2. Then we defined the center of this circle as P. We define the center of this circle as Q, and we define the center of the biggest circle as O. We define the point of tendency of tangent AB with this circle as T. We join points T and P together by a set line. Point P is the center of this circle. Point T is the point of the circle itself. Therefore, PT is the radius of this circle that is equal to A, and A equals to 2. The radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. Likewise, we define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to A, and N equals to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. So if BC is perpendicular to NP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. So inside the quadrilateral PTBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle must be equal, in total, they must be equal, those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, therefore the missing angle here must be equal to 90 degrees. So inside quadrilateral TPBN, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral TPBN is a rectangle, and we know that the opposite sides of rectangle are equal to each other. That is to say, Pn equals to TB, but Pn is 2, therefore TB is also 2. Likewise, in rectangle TPBN, TP equals to Bn, but TP is 2, therefore Bn is also 2. So AB is 5, TB is 2, therefore AB minus TB is 80. AB is 5, TB is 2, so 5 minus 2 is 3, so 80 is 3. According to rule number 2, that the lengths of two tangents from a common external point to a circle are equal, So from the common standpoint, point A, we have two tangents to this circle. Tangent 18, tangent AM. According to number 2, they are equal to each other. That is to say, AT equals to AM, but AT is free, therefore AM must be also equal to 3. AM is free, AN is 13 over 2. So AN minus AM equals to MN. Again, AN minus AM equals to MN. I repeat again. AN minus AM equals to MN. AN is 13 over 2 and AM is 3. So here we multiply 3 by 2 and then we multiply minus 3 by 2 and then we divide it by 2 in order to overcome a factor of 13 over 2. And found out that 13 over 2 minus 3 times 2 is minus 6 over 2. So in total this expression equals to 13 minus 6 over 2. 13 minus 6 is 7 over 2. So in total Mn equals to 7 over 2. So you can write here that this line segment Mn equals to 7 over 2 units in its length. Then I presented to you rule number 7 and we implemented rule number 7 in our drawing. According to rule number 7, if a line segment that is drawn from the center of a circle bisects a chord, then the line segment is perpendicular to the chord. The center of the circle is here at point O, and from the center of the circle we draw line segment OM that bisects chord AB. That is to say, AM equals to MB. Whenever you have a line segment from the center of the circle in the bisected chord, it must be also perpendicular to the chord. That is to say, OM is perpendicular to AB. It means that this angle equals to 90 degrees and this angle equals to 90 degrees. You can implement rule number 7 in our drawing. Why? Because in our drawing, point O is the center of the bigger circle. From point O, we join points O and then together by a straight line. ON bisect chord AC. Why? Because AN equals to NC. And because of the fact that ON bisect AC, ON must be also perpendicular to AC. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So you can write down that ON is perpendicular to tangent AC. Point Q is the center of this circle. Point N is the point of the circle itself. Therefore, Qn is the radius of this circle that is equal to B. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to Qn. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So you can write down also that Qn is also perpendicular to AC. Qn is also perpendicular to AC. And from those two equations, ON is perpendicular to AC and Qn is perpendicular to AC, we will derive that point O lies on Qn. Point O, that is the center of the biggest circle, must lie on the radius Qn. That is to say, QON is one straight line. QON is one straight line. Then we defined this point, that is the point of tendency of this circle with the biggest circle is U. Then we draw tangent VW, that is tangent to both circles at point U. To this circle and to the biggest circle, the tangent VW is tangent at point U to both circles. So here we have point Q is the center of this circle. Point U is the point of the circle itself, therefore QU is the radius of this circle. The radius QU is drawn to point U, therefore VW is perpendicular to the radius UQ. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So you can write down that QU, the radius QU, is perpendicular to tangent VW. radius QU or Q, it is the same, is perpendicular to tangent VW. Likewise, point O is the center of the bigger circle. Point U is the point of the bigger circle itself. Therefore, U is the radius of the bigger circle. That the radius of the bigger circle OU is drawn to point U, that is the point of tendency of tangent VW with the bigger circle. And therefore, tangent VW will be perpendicular to the radius UO. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So we can write down that OU is also perpendicular to VW. Yeah, OU is also perpendicular to VW. And from those two equations, QU is perpendicular to VW and OU is perpendicular to VW, we will derive that OQU is one straight line. Yeah, OQU is one straight line. That is to say, all the 3 points OQ and U are located on the same straight line. OQU is one straight line. So from one side, we just right now found out that OQU is one straight line. But from the other side, we also found out that OQN is also one straight line. And from those two statements, we will derive that in total, NQU is one straight line. Okay, NQU is one straight line. So if NQU is one straight line, it means that NU is also a straight line. But NU is a straight line that touches the circle at points N and U. Therefore, NU is a chord that passes for point Q, that is the center of the circle. And we know that any chord that passes for the center of the circle must be the diameter of the circle. Therefore, NU is the diameter of the circle. NU is the diameter of the circle, and we know that the diameter of any circle is twice as long as the radius, and the radius of this circle is b. Therefore, NU, the diameter, must be equal to 2b. NU equals to 2b. Then I presented to you rule number 9, and we implemented rule number 9 in our drawing. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together must pass for their touching point. The center of the big circle is 0 at point O, the center of this small circle is 0 at point M. The straight line that connects their centers together is the straight line OM. According to this rule number 9, the straight line OM must pass for point P. OM must pass for point P. That is to say, OMP is one straight line. OMP is one straight line. We can implement rule number 9 in our drawing. Why? Because in our drawing, the smallest circle touches the biggest circle at this point S. At point S, they have an interlant between them. The center of the biggest circle is 0 at point O. The center of the smallest circle is 0 at point P. The straight line that connects their centers together is OP. According to rule number 9, the straight line OP must pass for point S. That is to say, OPS is one straight line. Okay? Here, OPS is one straight line. According to rule number 9. So if OPS is a straight line, if OPS is a straight line, it means that OS is also a straight line, and OS minus PS equals to OP. Again, OS minus PS equals to OP. Repeat again. OS minus PS equals to OP or PO. OS, what is the definition of the straight line OS? It starts from point O, that is the center of the biggest circle, and then to point S, that is a point on the biggest circle itself. Therefore, OS is the radius of the biggest circle, that is equal to X. So you can substitute OS by X. What is the definition of PS? Line segment PS starts from the center of the smallest circle, that is to say from point P, and ends at point S, that is the point on the circle itself. This is exactly the definition of a radius. So PS is the radius of the smallest circle, that is equal to A, and A equals to 2. PS equals to 2, so we can substitute PS by 2. we will substitute PS by 2. So in conclusion, found out that PO equals to x minus 2. PO equals to x minus 2. This line segment PO or OP equals to x minus 2 units in its length. Then we extended the perpendicular ON by straight line. When you extend the straight line by straight line, the result is a straight line. So OT is a straight line. This is a straight line. If you focus on this side of the straight line, OT, at point N, the sum of the angles must be equal to 180 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at this side of the straight line OT at point N? We have this angle that is equal to 90 degrees plus the missing angle. In total, it must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. We know that CA is tangent to the smallest circle here at point M. Point M is the point of tendency. We join points P and M together by a straight line. Point P is the center of the circle, point M is the point of the circle itself, therefore PM is the radius of the circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency A with this circle, and whenever a radius that is drawn to the point of tendency, then tangent CA will be perpendicular to the radius MP. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees. In the next step, we draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So this angle equals to 90 degrees according to our construction. Then we extended the perpendicular until it touches the extended perpendicular ON. We define the touching point as T. In this way, we created quadrilateral MNTP. Inside quadrilateral MNTP, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. Therefore, quadrilateral MNPT with 4 right angles will relate to it as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise, here MN must be equal to PT in rectangle MNPT, but MN is 7 over 2, therefore PT is also 7 over 2. Then we define the length of line segment NO as H. And then I copied the right triangle OTP in a new page and we implemented the Pythagoras theorem on this right triangle OPT. This is the right triangle OPT that I copied from the original drawing. The hypotenuse PO is x minus 2. PT is 7 over 2. And what is the length of OT? OT equals to ON plus NT. That is to say, OT equals to ON, that is H, plus NT, that is 2. So in total, OT equals to H plus 2. Here, OT equals to H plus 2. So implemented the Pythagoras theorem on this right triangle OPT. According to the Pythagoras theorem, PO square equals to PT square plus OT square. PO is x minus 2, therefore PO square is x minus 2 square, and it equals to PT square. PT is 7 over 2, so therefore PT square is 7 over 2 square, that is 49 over 4, plus OT square. OT is h plus 2, therefore OT square is h plus 2 square. Then we opened brackets on both sides of the equation and found out that x minus 2 square equals to x square plus 2 square, that is 4, minus 4x, that is equals to 49 over 4, plus h plus 2 square. H plus 2 square equals to h square, plus 2 square, that is 4, plus 4h. Then I copied this equation here to a new page. This is the equation from the previous page in the COVID. In the next step, we join points O and C together by straight line. Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. This is exactly the definition of a radius. So OC is the radius of the biggest circle that is equal to x. ON is equals to h according to our definition, and we found out in the beginning of the lecture that NC equals to 13 over 2. So I copied the right triangle ONC in a new page and we implemented the Pythagoras theorem on the right triangle ONC. Okay, again, this is the right triangle ONC that I copied from the original drawing. Again, OC equals to x, ON equals to h, and NC equals to 13 over 2 according to the Pythagoras theorem in the right triangle ONC. OC square equals to ON square plus NC square. OC is x, therefore OC square is x square, and it is equal to ON square. ON is s, therefore ON square is s square, plus NC square. NC is 13 over 2, therefore NC square is 13 over 2, that is 169 over 4. So in conclusion, found out that x square equals to h square plus 169 over 4. Therefore, we can substitute x square in this equation by h square plus 169 over 4. We did it, and we got that x square is h square plus 169 over 4 plus 4 minus 4x, that is equal to 49 over 4 plus h square plus 4 plus 4h. We have h square on both sides of the equation, so h square will get cancelled. We have 4 on both sides of the equation. 4 also will get cancelled, and we left only this side of the equation. If 69 over 4 minus 4x, that is equals to 49 over 4 plus 4h. Here we added 49, we subtracted 49 over 4 from this equation and found out that 169 minus 49 over 4 minus 4x equals to 4h. Then we added 4x to this equation. 169 minus 49, it is 120, so in total this expression equals to 120 over 4, and is equals to, after we added 4x to this equation, we found out that 120 over 4 is 30, is equal to 4x plus 4h. Then we took 4 as a common factor from those two expressions. So inside the brackets we have x plus h. So in total we found out that 30 equals to 4 times x plus h. Then we divided this equation by 2 and finally we found out that 30 over 2 is 15. That is equal to 4 over 2 is 2. So in total 15 equals to 2 times x plus h. We divided this equation by 2 and finally we found out that x plus h equals to 15 over 2. What is the length of line segment UN? From the drawing it is very easy to see that UN equals to UO plus ON. So UN equals to UO, that is x, this is the radius of the biggest circle, plus ON, that is h. So in total, UN equals to x plus h. So we can write here that UN equals to x plus h from one side, but from the other side, we have already found out that UN is equal to 2b. Here, UN equals to 2b, it is the radius of the, it is the diameter of the circle, UN equals to 2b. So we can write here that UN is also equals to 2b. And from these two equations, from those two equations, UN equals to x plus h and UN equals to 2b, we will derive that x plus h equals to 2b. But we have already found out that x plus h equals to 15 over 2, so we can write here that x plus h equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b. We will derive that 15 over 2 equals to 2b. We divided this equation by 2 and found out finally that b equals to 15 over 2 over 2, that is 15 over 4. So the radius of this circle b equals to 15 over 4 units. And we have already found out that the radius of the smallest circle a equals to 2. A equals to 2 and b equals to 15 over 4. Therefore the ratio b over a, that is the ratio between the two radii, will be equal to b, that is 15 over 4, over 8, that is 2. 15 over 4 over 2 is 15 over 8. So in conclusion found out that b over a equals to either 15 over 8, or in terms of numbers it is equal to 1.875 without units. Again, the ratio between the radius of this circle and the radius of this circle, that is b over a, it is equals to either 15 over 8, or in terms of numbers it is equals to 1.875 without units. Okay, thank you very much.